All right, in this video we do an example from section 210 using on linear regression, and I'm going to show an example of how to get the answer that we're seeing in a certain homework problem from this particular section. Okay, we can see that there's some data given to us in this problem. This data may or may not have a meaning, but we'll just view this data as some numbers. And our goal in this video is to figure out where do the slope and y-intercept of the trend line for this data come from. How are we to obtain this answer for this given data set? Okay, so I'm going to show how to do the solution to this problem in Google Sheets. So I'm going to assume that you can find your way to Google Sheets. You can log into your AppState email account and find the icon, the Google Grid icon, and then open a new Google Sheet. And let me see, what we need to do here is, let's keep this simple first. I'm going to put in the data, create a scatter plot of this data. There's X and Y data given. So -2, our X values are spaced out every 1 unit in time, I don't know, -2 up to 3 in steps of 1. And then the Y value is -5, -3.8, -2.6, sorry, and -1.4, -0.2, and then finally okay, interesting, a +1. Okay, now you might notice here that we could create an average rate of change column. Okay, and we would notice that if we tried to compute the average rate of change, we could do that by doing -3.8 minus a -5, and then divide by the time spacing, which is let me see, -1 minus a -2. Hopefully we could figure out what that number comes out to be the average rate of change. So put an equal sign here, put an equal sign here, and that answer comes out to be 1.2. So the slope of the line between these 2 points is 1.2. But if I tried a different, 2 different data points, let's try these two, the change in the y would be -2.6 for a change of -3.8. So subtract the y values and then divide by 0 minus 1. Ask the computer to compute that quantity, and we're seeing here that there is a interesting. Did I do that in the backwards order? Let me check that. -2.6 minus a -3.8, and then 0 minus 1. So let me just explain why I'm a little confused here. I'm going to create a scatter plot, and I'm going to insert a chart for this data, and we're going to create a scatter plot. And you know, this scatter plot it's hard to kind of tell here if all of those data points lie on one particular line. So I was looking at the slope between these 2 points, the first 2 points, and that's what we found the average rate of change to be a +1.2. Then I was trying to look at the next 2 data points and compute their average rate of change, and I got a negative number, which seems to believe that the data points slope downward. So I think I just have a minus sign error, -2.6 to -3.8, 0 minus, yeah, right here, this should be a -1, 0 minus a -1. Okay, so there we have these 2 data points, the constant average rate of change. So it looks like those 3 points are on the same line. But so we don't have to compute the average rate of change between all the other points to see if they're constant. Why don't we ask instead the question, can we find a trend line for this data, right? Is there a line that best fits this data? And the way to do that, and we will interpret the results in a moment. Let me move this plot up here. Let's highlight the data. Okay, and highlight the data, and then up comes that series. We want, where did it go? Series, and under series, we're looking for the trend line, the line that best fits that data. And then one can click the label to use the equation, and one can see that where the 1.2 is coming from, right? The 1.2 is the slope, the average rate of change that we already computed. So it looks like in this case that there is a line that goes exactly through each of those data points, because all those data points, if we computed the average rate of change between them, we would get a value of 1.2 for the average rate of change, a constant average rate of change. Okay, so this trend line, let's look at this. We can see from the chart that these data points are best fit by a line of slope 1.2 and a y-intercept of negative 2.6. And so when one is putting the answer, right, to this problem, we can go back here, that they want the equation y is equal to mx plus b. We can see here that the m value we're getting from right here in the trend line, that would be 1.2, and we are getting a b value from right here of negative 2.6. Okay, so this does not always have to happen where the data points you're given that there is a line that goes exactly through them. So in this case, the trend line is the line that goes exactly through them. But we've seen in the previous video that not all data has a line that goes exactly through all of it. There is a best fit line, and that best fit line is not necessarily going to go through all the data points. So this is the example that we're seeing here on the screen is a special case of the trend line where the data actually is linear. Okay, so ends this video.